Fire in an industrial building. Smoke penetrates through unsealed doors. For people within the building, it is difficult or almost impossible to escape through the smoke. Building material and construction parts have to withstand the extreme heat. If the smoke and heat cannot be released to the outside, the inflammation point is soon reached. And if just a door is opened, a flashover through the whole building is caused by the inflow of oxygen. Successful firefighting always depends on the grade of smoke logging. To localize the source of fire, firefighters have to wear oxygen masks to get through the smoke. To ensure successful firefighting and keep escapeways smoke-free, a correctly designed smoke extraction system is an important factor within an effective fire safety concept. The diagram shows clearly that especially in the first 10 minutes after the start of a fire, the temperature is low, but the development of smoke is extreme. Therefore, people do not perish due to the heat or the fire, they are killed by breathing the toxic smoke. By burning 100 kilograms of paper, a smoke volume of 20,000 cubic meters can be produced within 10 minutes. This is the volume of a building 100 meters long, 25 meters wide and 8 meters high. If a smoke and heat extraction system is installed, the temperatures are considerably lower and the hot smoke is released to the outside, which is shown in the second diagram. This film was produced in order to understand more about the function of smoke and heat extraction systems. The model test shows this quite clearly. Our industrial building has natural smoke extraction ventilators in the roof and side windows in the side walls. The source of smoke is ignited. Smoke rises due to thermal temperature vertically upwards and spreads under the ceiling with a velocity of up to 10 meters per second until it reaches the side walls. If this distance is more than 40 meters, the smoke cools down and flows back to the fire as a smoke roller. After a short time, the workers and machines are hidden in a smoke-logged building. According to the experience of psychologists and fire brigades, people panic at a visibility of 10 meters. The natural smoke ventilators are opened. It can be seen that just a little smoke is released. Now the side windows are opened to allow for inlet air. Smoke also escapes through the open windows. Although the inlet windows are open, there is only a little smoke release through the smoke ventilators in the roof. The test shows that smoke extraction in a completely smoked log building takes a very long time, although smoke extraction ventilators and inlet air windows are open. To subdivide the roof space into smoke sections, smoke curtains can be installed. Sometimes roof trusses are used as effective smoke curtains. but they are not high enough and most often not smoke tight up to the roof. We will see if the smoke stays in the smoke section above the fire. Our smoke curtain is similar to a roof truss which is not smoke tight up to the roof. The natural smoke extraction ventilators are closed and the smoke source is ignited. Right at the beginning we can see how the smoke spreads under the ceiling and how the smoke penetrates through the gaps between the roof trusses and the ceiling. As the smoke layer becomes thicker than the roof truss, the smoke flows also into the next roof section, until the whole building is smoke logged. We repeat this test by using a smoke curtain which is half the height of the building and is connected tightly to the roof. The gaps between roof and purlins are closed smoke tight. If rigid smoke curtains cannot be installed because e-transport cranes hinder, automatic movable smoke curtains can be used. Because of the tight connection to the roof, no smoke gets to the other smoke section in the roof space. Even as the fire develops and more smoke is produced, the smoke falls down at the smoke curtain and does not enter the other smoke section. The smoke section to the right remains smoke-free for the time being, but will be smoke logged too when no smoke extraction system is installed in the left section and the smoke is not released to the outside. The next test shows the function of an expert smoke extraction system. At the early stage of a fire, the smoke extraction ventilators as well as the inlet air units open. The smoke is immediately extracted and stays within the smoke section. The smoke sector at the right remains smoke-free due to the well-designed smoke curtain. In the left section, a smoke layer builds up in the roof space. The floor area is kept smoke-free. Therefore, people can escape without any problem. The firefighters can localize the source of the fire easily and start a specific fire attack. Sometimes it is impossible to install inlet air units in the outside walls, or the essential inlet area cannot be supplied. It has proved to be a good substitutional solution to use extraction openings for inlet air, if smoke sections are created by smoke curtains. In this case, the natural smoke extraction units in the smoke-free area work as inlet air units, as can be clearly seen by the smoke flag. The smoke extraction ventilators in the smoke-logged section work as natural smoke extraction ventilators. The inlet air units still bring inlet air in, demonstrated by the smoke flag. The different tests show that natural smoke extraction works best when the system is initiated at the very early stage of a fire and the necessary inlet area is open. In addition, the tests have shown that smoke curtains have to be planned seriously to fulfill their purpose. The function of a natural smoke extraction system will now be proved by a reality test. A natural smoke extraction system installed in an industrial building with an automatic smoke curtain fixed at the trusses in the roof space is available. The trusses are smoke tight up to the roof construction. Now we produce smoke. As soon as the smoke detector reacts, the automatic smoke curtain is released and divides the building into two smoke sections. As shown in the model test, one section remains smoke-free. Without a natural smoke extraction system, the building would soon become smoke-logged. Escaping becomes almost impossible. For the firefighters, it becomes very difficult to find the source of the fire. To rescue people and to successfully fight the fire without oxygen masks becomes impossible. To avoid this situation in a real fire, the natural smoke ventilators are initiated at a very early stage. The smoke ventilators are opened by smoke detectors or thermal overriding carbon dioxide valves. They can also be released manually. Now the smoke is extracted quickly to the outside of the building and the firefighters can fight the fire without oxygen masks and walk with the inlet airstream towards the fire. In a professionally designed fire safety concept in which smoke extraction is an important factor, damages as shown here could have been considerably reduced. To sum up, one can say that a natural smoke extraction system guarantees the effective smoke and heat extraction in case of a fire and keeps escape ways smoke-free. Smoke extraction enables effective firefighting for the fire brigade and reduces the total damage caused by a fire. The design of a natural smoke and heat extraction system and the execution on site has to be done according to DIN 18232-2 or corresponding national guidelines. Further information can be obtained from specialized experts and companies or insurance companies and specialized experts in natural smoke and heat extraction systems. After installation of a smoke extraction system, the company owner receives a complete documentation of the system installed, including number and size of vents, calculations and controls. To secure the function of a smoke extraction system, a yearly maintenance is essential. Only a professionally designed smoke extraction system can guarantee the defined fire protection targets.